Last section of chapter 5, systems of linear inequalities. So we're going to finish up chapter 5 today. We'll get another assignment over it on Monday. And then after that, it's going to be review and test from there on out. So you'll get 6 days of review for the semester test. And then the last 2 days of school are the semester tests, but you only get 1 day to work on it in my class. The day that you guys are taking it is Wednesday, the second to last day of school. And then that Thursday, in the afternoon, there'll be some yearbook signing party or something like that. You're so excited. Okay. So that's the plan of action for the next 2 weeks when I'm not here. You get 1 day with an assignment over this stuff that we're learning today. 6 days of test review. And then a day of test.
How big is the test?
And then after that. So the test, I'm making it's either 14 or 15 questions. Okay? We've covered 5 chapters this semester, so I try to pull 2-ish to 3-ish from each chapter. Okay? But you'll get 6 days of review before it. Everyone good with that? It's all multiple choice. You'll have a bubble sheet, so you're not going to be writing on the test. Then you'll use a scratch piece of paper for your work.
So
okay?
odds are on Wednesday?
No. Wednesday it is 5th, 6th, 7th hours.
Oh, wow.
Thursday is 1st, 2nd, 3rd, 4th.
Okay.
They did that because of the yearbook signing party on the last day of school. Okay?
So for the yearbook signing party, is everybody allowed on?
I don't know how they're going to handle it, and I honestly haven't cared too much because I won't be here. So, sorry. You're welcome. So let's go ahead and get into our notes for today. Systems of linear inequalities. So we've talked about systems of equations, correct? Now we're going to talk about systems of inequalities. So it's very similar to a system of equations. System of linear inequalities is just a set of 2 or more inequalities in the same variables. An example is shown below. So a system of equations was 2 or more equations in the same variable. System of inequalities, a set of 2 or more inequalities in the same variable. So the example they give is y is less than x plus 2, and y is greater than or equal to 2x minus 1. That's a system of linear inequalities right there. A solution of a system of linear inequalities in 2 variables is an ordered pair that is a solution of each inequality in the system. So just because the ordered pair fits the first inequality does not mean that it's a solution for that system. It has to fit both inequalities for it to be a solution of the system. Same thing for the other one. Just because it's a solution of the second inequality doesn't necessarily mean it's a solution of the system. It has to be true for both inequalities for it to be a solution of the system. Any confusion on that concept? Can I go ahead and move on?
No.
Okay, I'm waiting a little bit. Question?
Me?
Yeah.
Oh, no.
Okay.
By the way, I found a really cool app. It's called Socratic. It doesn't give
On.
I'm really excited when I
Example 1, checking solutions. It says tell whether each ordered pair is a solution of the system of linear inequalities. So my system is y is less than 2x. Y is greater than or equal to x plus 1. For letter A, it gives me the ordered pair 3, 5. What's my x value in that ordered pair? 3. Golly, let me write. There we go. That's ugly. My x value is 3. What's my y value? 5. That's how an ordered pair will always be. X will always come first, y will always come second. How do I check to see if this is a solution of my system?
plug in X and Y.
Plug in x and y to what?
both equations.
Both inequalities, not equations. I know, I mess that up sometimes too. I'll sometimes call them equations. They're not equations though. They are inequalities. So what do we say our y value was?
5.
So 5 is less than 2 times x. What's x? 3. What's 2 times 3? 6. Is 5 less than 6? Yes, it is. So it makes my first inequality true. Checks out for that first one. Am I good to just stop there and say it is a solution?
Yes.
No. I got to plug it into the other one. Like I said, just because it fits the first one does not necessarily mean it fits the second one. So I got to plug into the second one also. 5 is greater than or equal to 3 plus 1. What's 3 plus 1? Is 5 greater than or equal to 4? It does? It is?
No.
It checks out? Yes. It's greater than. So when it's greater than or equal to, it just has to fit one of those. So as long as it's either greater than 4 or equal to 4, it's a true statement. Does that make sense? Okay. So 5 is greater than 4, is it not? It is. It works for that second inequality. So I can say 3 comma 5 is a solution.
Well.
Everyone good with that? It's a solution of my system of inequalities.
Are we on record?
Then?
I don't know what happened there. It just flipped.
Questions on example A? 1A. Can I move to B? What's my x value on B? -2. What's my y value? 0. Once again, I got to plug my order pair in to both inequalities. So plugging into my first one, we said our y value was 0 is less than 2 times -2. What's 2 times -2? -4. Is 0 less than -4? It is not. So, I don't even have to do anything with my second inequality because it doesn't fit my first one. I can go ahead and say that -2, 0 is not a solution. Any questions on how to check to see if it's a solution or not?
So why did we say it was not a solution?
Because it makes, if I plug it into my first inequality, it gives me a false statement.
So we don't have to do this.
Yep, because it has to fit both, remember?
Yeah.
So if it doesn't fit my first one, there's no need in doing my second one, unless you absolutely want to. I don't want to, though, so go for it if you want to. Questions on example 1? Yep. Okay, let's talk about graphing. The graph of a system of linear inequalities is the graph of all the solutions of the system. So when we graphed our equation, what was my solution? Like if we had a system of equations, what was my solution?
3.
What? Okay. If I have a system of equations, what is my solution? One ordered pair, right? Which ordered pair?
3 and 5.
Like graphically.
Excellent.
One within the shaded area?
X.
Ones that intersect.
Where they intersect, right? If I have a system of equations, don't think inequalities, think equations now. Where they intersected, that one ordered pair was my answer, right? Now let's talk about inequalities. Yesterday, we graphed one inequality at a time. What was my solution? Yesterday.
Oh.
And the day before that.
There.
What?
An order pair.
Not just one ordered pair.
It's you when you. It was about like the shading part.
The shaded region, right? So it was a bunch of ordered pairs. So when I have a system of inequalities, you can probably guess we're probably going to graph them on the same graph. Instead of just the intersection as my solution, it's going to be the intersection of the shaded regions. So a shaded area is still going to be my solution today. Okay? So let's look at a little graphic of that. So step 1, graph each inequality in the same coordinate plane. So you graph it on the same graph. Find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph of the system. So, here's our example right here. I have y is greater than or equal to 2x minus 1. So here's that line. If I was just graphing that one by itself, I would shade above it because it's greater than, correct? So it'd be everything above this red line. This pinkish area and this purplish area. Red, I guess. Here's my other inequality. Y is less than x plus 2. So here's my line. It's shaded below this line because it's less than. So when I have those graphs on top of each other, my solution is the area where the shaded regions are on top of each other. So that's this little triangular-ish type piece. Right here. That shaded region is my solution because that's where the shaded areas overlap. Does that make sense? So once again, it's just not the ordered pair where they intersect. It's all the ordered pairs where the shaded regions are on top of each other. Did I answer your question? Okay, perfect. Any questions on that? And I'll show you a couple ways on how we can shade our solution. Can I move on? So here's an example. Graph the system of linear inequalities. Y is less than or equal to 3. Y is greater than x plus 2. So what I like to do first, I just like to graph both boundary lines and don't do any shading at all. I like to get both lines on there first before I shade. So how do I graph y equals 3?
Go to the third, like, y thing. 3 on the y graph, positive 3. And you just, like, shade horizontal.
Very good. This is poi, because it's just y and a number. So I know it's going to be a horizontal line crossing my y-axis at the value 3. So I'm good with that. And is this a solid or dashed line? Solid. So it's a solid line going through 3 on my y-axis.
Very straight line.
Thank you.
The other one.
That's okay. You guys get the gist, right?
Yeah.
There's my first boundary line of my first inequality. Let's look at the second boundary line. What's my y-intercept of that line?
2.
Positive 2. So I put a point at 2 on my y-axis. What's my slope? 1 over 1. So I'm going up 1, right 1. Everyone good? Graphing using slope-intercept form.
Yeah.
What other two directions can I go?
Down one.
Down 1, left 1. And is this a solid or dashed line?
Yeah.
It's a dashed line. Any questions on how I got either boundary line?
No.
Okay. Here's the way that I like to shade. Let's look at my first boundary line. It's y is less than or equal to 3. Based on my inequality symbol, am I shading above or below this line? Below, because it's less than, right? So if you notice, our boundary lines cut our graph into pretty much 4 sections. One right here, one right here, one right here, and one right here. Does everyone see that?
Yes.
So, remember, the solution to my system of inequalities is the overlap of the shaded area, right? So if I'm shading below this black line, can my solution be either of the sections above it? No. So I like to cross those off. Put a big X on them. I know I'm not using those as my solution. Because I know it has to be below that line. Does that make sense?
Yeah.
Now I use the other inequality to get the actual solution. For y is greater than or equal, for y is greater than x plus 2, am I shading above or below that line?
Above.
Above. So can my shaded area be below that line?
No.
No, so I'm going to put a big X on it. I'm left with one shaded region, right? So I'm going to shade that area in. And that's my solution. Everyone good with that? Any confusion there?
No.
Another way you can look at it is similar to the way we just saw it on the previous slide. Erase my X's and stuff. So, y is less than or equal to 3. We said we shade below that line, right? So I could shade below that line. Everything below that line. I'm just shading. And then y is greater than x plus 2. Am I shading above or below that line? Above. I can shade above that line. And then you can see where they're overlapping, right? Where there's black and red. If you're using your pencil, you would just make this section darker than the other two. So you darken it in a little bit. If you're using this method, where you're doing the light shading up here and here, make sure your solution area is darker than the other sections. If they're all three the same amount of shading, I'm not going to be able to tell which one you think is the solution. That's why I like crossing the sections off that I don't need, because it's very clear which section I do want as my solution. But you can use either way, just make sure I can tell which one it is. Everyone good with that? Any questions? You can use either one. Can I move on? All right. Graph the system of linear inequalities. 2x plus y is less than negative 1. 2x plus y is greater than 3. Yep, you are all saying the same thing. We want to get it into slope-intercept form for us to be able to graph it. So my first inequality, how do I get y by itself? Subtract 2x from both sides. So I get y is less than negative 2x minus 1. Everyone good with that? What do I do for the second inequality to get y by itself? Subtract 2x from both sides. So I get y is greater than negative 2x plus 3. Any questions on that? Based on my slopes, what kind of lines are these going to be?
Parallel.
Parallel. Whenever we did systems of equations, if we got parallel lines, what did we say? No solution, because we were looking for the intersection of the lines. Are we looking for the intersections of the lines here? No, I'm looking for the intersection of the shaded regions. So just because they're parallel does not mean in this case that there is no solution. In this case it does, I put it up here. I know it's no solution. But let's see why. We're looking for the overlap of the shaded area. So let's see where we're shading with this. Okay? For my first inequality, what's my y-intercept? Negative 1. What's my slope? Down 2, right 1. And up to left 1. Solid or dashed line? Dashed. There's my first boundary line. Questions on it? What's the y-intercept of my second boundary line? Positive 3. Same slope, right?
Yeah.
Down 2, right 1. And up 2, left 1. Solid or dashed line? Dashed. So there's my two boundary lines. Let's go ahead and shade both of these and actually do the shading, not just the x's. Or I guess we could do both. We'll do the shading first. For my first boundary line, this black dashed line, am I shading above or below it? Below, because it's less than. So I'd be shading everything below that line. Everyone good with that? For my second boundary line, am I shading above or below it? Above it. These boundary lines are going to go on forever and ever and ever. So are these shaded areas ever going to touch each other?
No.
They're not. So, what's my answer here? No solution.
Zero.
Does everyone see why it's no solution? Yes.
What if the second one was also a less than what was?
If my second one was also a less than, I'd be shading everything below this line, right? So the intersection of the shaded area would be below this black line.
Okay.
Does that make sense? So I'd have a solution there.
Okay.
Okay? If one was, let's say this one was greater than, this one was less than, they were flipped, the shaded area would be between the lines. Everyone good with that? If you were using the X method, I guess we'll call it, you can still use that method here. Let's see what it would look like. For the first one, I'm shading below it. So can it be either section above it? No. So I'd cross out that middle section and this big section up here. For my second one, I'm shading above it, so I can't use anything below it, can I? So that'd be the middle section again, and this bottom section. So as you can see, I don't have any sections left to shade in, do I?
No.
So that's another reason it's no solution. Or another way to see it's no solution. Questions on example 3?
No.
We good with that? Can I move on? 2 more examples real quick. These kind of go a little quicker than the previous ones. Now it gives us a graph, and it wants us to write a system of linear inequalities represented by the graph. So I'm kind of working backwards from what I've been doing. So let's go ahead and construct our inequalities. Let's look at the dashed line first. What's my y-intercept of the dashed line?
0.
0. Do I need to put plus 0?
No.
No. And what's my slope?
1.
1. 1 over 1. Do I need to put the 1 in front of the x? No. So it's going to be y on the left, x on the right. I just have to figure out the inequality symbol from here based on the shading of my graph and what type of line it is. So is it dashed or solid? Dashed. So it's going to have a line under it or no? No. Am I shading above or below that line? Below. So is it less than or greater than? Less than. There's my first inequality. I know we walked through that kind of quick, but do we see how we constructed that inequality?
Yes.
Okay? My solid line is a horizontal line. So what's the form of that going to be?
It's not going to have a slope.
The slope's 0, but which variables are not going to be?
It's not
It's not going to have an x. So it's going to be y on the left and some number on the right. What is that number?
Negative 2.
-2, because it's crossing my y-axis at -2. Solid or dashed line? Solid, so I now have a line underneath my inequality symbol. Am I shading above or below that line? So it'd be greater than or equal to. Here would be my system of inequalities. Questions on example 4? I feel like those are decently easy.
Yes.
Last example. Same thing. Gives me a graph. It wants me to write my system of inequalities. Let's look at the dashed line first. What's my y-intercept?
1.
Nope,
Which line are we doing first?
the dashed line. It is not 1.
2.
It is not 2.
Oh, it's -1.
-1. Don't be tricked. My y-axis is over here.
Oh, I thought
Crossing
that,
it.
I
Yeah.
thought that blue line.
That tripped up first hour also.
Oh, I cannot see that.
What's my slope?
One.
Nope.
Oh, I don't know.
Wait, I can't see.
1 over 3. No.
So I got a point
Negative 2.
here. I've got a point here.
Oh,
What's my rise over run to get from that point to that point?
2 over 4.
Nope.
Is it 2 over 3?
2 over 3.
What the heck?
You rise it going up 2. 1, 2. 1, 2, 3. Up 2, right 3. Questions on that one?
No.
What's my inequality symbol going to be?
Greater than?
Yeah, greater than.
Just greater than, right? It's shaded above my line, so I know it's greater than. And it's dashed, so it's not equal to. Okay, now let's look at the second inequality. It's a vertical line, so what form is that going to take? X and some number on the right. What number is that? 3, because it's crossing my x-axis at 3. What's my inequality symbol?
Greater than. Or equal
It's less than or equal to, because it's shaded to the left
to. Oh, yeah.
of my line. The numbers left of 3 are the numbers that are smaller than 3. So it's less than or equal to because it's a solid line. Here's my system of inequalities. Questions on example 5? Here's the assignment. Write it down. Pages 268 through 269, numbers 4 through 30, evens. It'll be due Tuesday on Canvas. While I'm gone, I'm still going to be grading stuff. So don't say, oh, Mr. McAllister's not going to be here, so I don't have to turn anything in. It's not the case. If you don't turn it in, you still get a 0.
Can I
But-
use my phone book?
Yep. Any questions before I end my recording?